review from yesterday, AC and DC bell work. Yeah, electric chairs, they generate electricity from generators like this. So you have a magnet right here, and you have a magnet here and here. So the important part of this is the direction of the magnet. So let's say this is positive, that would be positive, that would be positive. This would be your negative. Everybody clear on a magnet, there's a positive, different poles, right? So the point here is that as this rotates, this wire rotates through this magnetic field, right? You have an alternating current that's developed. This is AC. DC motor, where you just have one polar magnet where you have like a north pole and a south pole, and you're not going to get any variation in the current that's being produced. That makes sense? This is the simplest one. Obviously DC was most likely discovered first. And which one of these did Edison work on? AC or DC? DC. Edison was working on a direct current. It was Tesla who kind of came up with a better idea with the AC current. AC current you can transport at a greater distance, and Tesla won the contest and exhibited his project in the 1893 World Fair. And from there was still a lot of work that had to be done as far as who was going to back Tesla. Tesla ended up getting bought out because he didn't have the money to build the facilities that he needed to generate the electricity. Whereas the financial backing was really behind Edison at that time because everybody thought Edison was smarter. So Edison lost out pretty big. The name of the company changed from Edison to, I think, General Electric because of this shift. What it would look like if you were to draw a wave as you created the alternating current. Now, you have to spin this. That's when you burn coal, create steam, and you push that steam through, I guess, a system where it's comes out with higher pressure. You know, you understand that? Water can create pressure to heat it. So the pressure is what turns this wheel, yeah. And you can use water as well to turn the wheel, but you have to turn the wheel. You're not going to get electricity unless you turn this. Everybody understand? Turning is what generates the electricity. And that's AC as well. It's constant next semester, but Michael Faraday used the battery in the groundbreaking studies of electromagnetism. But it also talks about telegraphs were used. It was used to power telegraphs as well. Sophia? Okay, very good. And 32. Though initially galvanized by the work of Luigi Galvani, argued that the frog's muscles were simply reacting to the electricity, not producing it. He set out to prove Galvani wrong and sparked controversy that divided the Italian scientific community. So he uses this battery that he makes to prove activity series of the metals. Okay, here's an example of the chlorine. It's kind of a single replacement reaction in the sense that you have the brine solution reacting with one of the two metals here, it's going to favor the zinc based on the activity series. Similar lab we're going to do tomorrow is going to show this with the copper chloride reacting with the aluminum. We're examining today JJ Thompson, and in 1897 he used the electrode or the cathode ray to identify the electrons in a magnet. And we just discussed that in 1893, the World's Fair happened. That's where Tesla used magnets. So people thought magnets were kind of like magic. You can use magnets to make things go very fast. Magicians do this. That's how they fool your eye. They say, look over here, and then they use a magnet, and they can get things to go really fast. So magnets are kind of like magic. See that magic there? Look at this. Wow. There's no glue there at all. So JJ Thompson was interested in magnets. He wanted to know what was going on. So he sets up this cathode ray. We have one of these at school, but I don't like using it because it creates a lot of like radiation. And I don't like, I'm older now, I don't like being around a lot of radiation. So he creates this tube, and the electrons flow through it. And he places the magnet on the top, and you can see how the magnet is, or the electrons are drawn to the magnet. They actually kind of move up there, which is really nice. And he showed that the electrons coming out of the tube were the same that was in the magnet. So the magnet right here is really what people were interested in. They didn't know what was happening there. If you ever play with magnets, you feel that bond that's happening, you can feel, wow, there's kind of something going on there. Nobody knew what was going on. Prior to JJ, nobody had a model of the atom. Dalton didn't produce a model. Democritus didn't produce a model. So JJ's like, look, we can make a model now because I've determined what this is. I've shown you that they're similar. It's the same thing. The magnet is affecting the cathode ray. These are electrons. This was generated by an electrical current. So they knew electricity and lightning were the same thing. Who showed us that? Lightning? Yeah, Ben Franklin. He showed us they were the same thing. So we have our electrons now. And what kind of model did JJ come up with? How do you know? How could he prove there was a model? How could he prove there was a model of the atom with this? Anybody? Well, they're separate. This is happening, we're not adding anything to it, right? This is just happening on its own independently. So the electrons must be associated with the structure of the atom because of the independence happening here. That's the conclusion. That's an argument he made, and he was correct. See how there's nothing being added here, it's kind of doing it on its own, right? We'll talk more later why this happens. But he came up with a model. You might know what the model's called? I would have called it the chocolate chip cookie model, but he came up with plum pudding. This reaction right here, it may seem like it is a single replacement reaction because you have the brine solution and you have these different metals in competition, but it's actually oxidation reduction reaction because these metals are actually changing their charge. They're going from zero, all elements have a zero charge, to a charged ion. So the zinc here is becoming charged. Now the silver can as well, but the chlorine prefers the zinc over the two. And because you have a change in charge, it's oxidation reduction reaction. So you might want to remember that. 16. Dan?
Which is the type of substance?
17. Okay.
The diameter of a carbon atom is 0.000, that long number. What is this number expressed in scientific notation? And I put C.
18. Carlos?
Precautions do you take when you see the status quo? I put
19. Let's go with Diana.
Which state of matter is characterized by having a definite shape and definite volume?
And 20. Let's go with Gabrielle.
Which of the following is a C.
And 21. Okay.
Matter that has a uniform and unchanging composition is known as the
22. Austin. 49. Gabriel.
Which of the following is a physical property?
50. Okay.
How many significant digits are in the value? That one. D.
Correct. The first scientist to isolate methane gas. Basically, he was in a swamp and he saw some bubbling happening there and he wondered what it was. So he discovered methane gas by isolating it and testing it. Found that it was a gas unlike oxygen and hydrogen. So he worked with electricity. And if you note right here, Volta put a stack of metals together. But the important thing you need to note is that he separated them with a brine-soaked cloth. So here's your set of metals, different metals. There were silver and zinc discs. He separated them with a brine cloth. Now what is the brine cloth going to do? So brine would be like salt water. And what it's going to do, it's going to cause, start to see, raise your hand. Go to Florida, you're going to see more of this, starts to see chemical change. No. On your car, call it rust. Corrosion, yes. Competition with a guy by the name of Luigi Galvani. And Galvani believed that there was something called animal electricity. Raise your hand if you've ever heard of animal electricity. Okay, so he thought that you could take like metal and touch a frog with it and the frog leg would move. So he thought that the animal was creating this electricity. And Volta, he didn't think that. He thought they were separate. He thought electricity was electricity. He didn't think animals were producing it. So he had to come up with a way to convince society at this time that he was correct. He was an Italian physician, and he was experimenting with dissecting frogs and their attached spinal cords mounted on iron or brass hooks. In most of his experiments, the frog leg could be made to twitch when touched with a probe made of another metal. The frog legs would also jump when hanging on a metal fence in a lightning storm. These observations convinced Galvani that he had found a new form of electricity which was being generated by the frog's muscles. And that was the animal electricity. Exclusively that the generation of electric current did not require any animal parts, Volta put together a rather messy stack of alternating zinc and silver discs separated by the brine-soaked cloth. He built the pile and considered, which consisted of as many as 30 discs in a imitation of an electric organ of the torpedo fish. So he kind of modeled it after a fish. This was actually used by other scientists to create like doorbells and other useful things. Zinc. Zinc? Ethan? Zinc is more reactive. Silver or zinc? Josh? Zinc is more reactive. Why? I know why?
Because it's more expensive.
Well, silver is a transition metal. That means it can have more than one charge. It can lose more than one set of electrons. But zinc is considered to be a main group, and actually I think it might even be transition too. But zinc tends to be a little bit, I guess you would say, closer to the main group. So let's find it on the periodic table real quick, just so we can kind of compare the two. So zinc is found in group 12 on the periodic table, whereas silver is found in group 11. So they're very close to each other. But zinc is smaller. It has 30 protons, and silver has 47. So zinc is closer to the main group by one group than silver is. So they're both transition metals. That means they can have more than one charge. So they're both unpredictable, right? Now, why is zinc more active? Maybe it's just closer to the main group. The closer you are to something, the more like you tend to be. Like there's an old saying, the apple doesn't fall far from the tree. Good every once in a while. Right? 1897, they did not have magnets.
They didn't have magnets, sir.
Yes, they did. I just told you Tesla used them to generate electricity. 1997, did we have access to magnets? Did magnets exist? Raise your hand. Ethan?
No.
No. Noah?
No.
No. Raise your hand if you agree with them. You don't have a pretty good audience. Raise your hand if you think magnets did exist in 1897.
I know it's...
Rachel? Correct. Emma?
Correct.
Correct. Yes, the magnets did exist back then. If you remember bell work, right, bell work we talked about, we're progressing, right, from a timeline. Edison and Tesla both worked with magnets to do what? Raise your hand. Do what? What were they trying to make?
Batteries.
Batteries.
Electricity.
Electricity, right. So magnets are used to generate electricity, if you didn't know that.